Today we're going to look at section 1.4, solving literal equations. Our main objective today is to be able to solve for a specific variable in a literal equation. First, we need to know what a literal equation is. A literal equation is any equation that has more than one variable in it. For example, y equals mx plus b. That is a literal equation, more than one variable. And what I'm going to do today is pick one of them and ask you to isolate or solve for that one variable. Example 1, I want you to solve for y. So what I'm going to do is identify where the y is, and then do whatever I can, algebraically, to get that all by itself. So in this case, I'm going to subtract 3x. That would isolate the negative 7y. Don't forget to drop down the negative. These are not like terms, so I'm going to just leave it as 21 minus 3x. Again, I'm going to kind of think about what I'm trying to get alone. It's negative 7 times y, so opposite operation of multiplication is to divide. So this will leave me with y equals 21 minus 3x all over a negative 7. Now technically you have done what I asked. This would be fine for a final answer for me. Some people prefer to break this up into two smaller fractions, which is okay. You could divide 21 by negative 7 and get negative 3. Divide negative 3x divided by negative 7, get a positive 3x over 7. This is also an okay answer. However, if you don't feel comfortable going from here to here, and you do that on a quiz or test and do it incorrectly, you will be marked wrong for it, even though you got to a correct answer here. So please be careful with your algebra. Let's look at example 2. Example 2 is now asking us to solve for t. So if I look through here, there's actually more than one t. There's a t on the left-hand side and the right-hand side, which is going to make it a little bit more difficult. So what I want to do is, because I see a fraction equal to a fraction, I want to cross-multiply. So I'm going to show you what that's going to look like. 7r, I'm going to do this diagonal first, times 3t minus 4. Now, I know most people will probably just distribute right away in their head, but I'm going to write it out just so you can see each individual step. Now I'm going to do this diagonal, 5t plus 1. Again, let me identify where the t's are now. Right now, they happen to be trapped inside these parentheses. The only way I can get them outside the parentheses is to distribute. So I'm going to distribute 7r on this side, which is going to give me a 21rt minus a 28r. On the right-hand side, if I distribute 8r, I'm going to get a 40rt plus 8r. Again, let me just show you where the t's are. Now, when it says solve for t, it doesn't say solve for the two random t's. It's solving for a single t. So what I need to do is get these all onto one side. It does not matter if it's the left or right. I know most people tend to move things to the left, so that's what I'm going to do. So I'm going to subtract 40rt from both sides to get the t's on the same side. Now, because these are like terms, and the only reason I know they're like terms is because they have the same variables, r and t, I can subtract them. So 21 minus 40 is going to give me a negative 19rt minus 28r equals 8r. Okay. Now if I isolate the t, now I only have one box. Now that's your main goal, is to get it down to just a single t being boxed. Okay, so now I know I've at least combined 1 from 2 to 1. So it's still not alone, so I'm going to add 28r to both sides, which leaves me with a negative 19rt equal to, if I add these, a 36r. Again, this is what I want to get alone. But the t is being multiplied by a negative 19r. I can do a division of negative 19r all in one step. So it gives me a t equals 36r over negative 19r. Now, technically you've got t all by itself. However, you can do some simplifying. The other one, I didn't simplify anything. I did a little bit, but it was really changing the form. But this one, it's blatant that there's two r's. So you do want to rewrite this as t equals 36 over 19. Now, usually we put the negative in front. It is okay if you leave it in the denominator, but typically we put it in the numerator. There is no term that goes into both 36 and 19, so we know it's simplified all the way. Let's look at example 3. In this one, I want you to solve for w. Again, Maybe a little bit trickier because there's a W on the left and the right-hand side. However, the left-hand side is the only one where it's trapped inside this parenthesis. So just like last time, we're going to distribute to get it outside of our parenthesis. On the right-hand side, I have nothing to do. So I'm going to just think about where the W's are. They're not on the same side, and you always want them to be on the same side so I can combine them and get one W. So what I'm going to do is subtract 8W from both sides. That leaves me with a 9x. 9W minus 8W is just positive 1W. You can write the 1. I'm going to choose not to. And now I'm down to a single W, one box. But this 9x needs to be moved to the other side. And drop down the W. These are not like terms, so I'm just going to leave a y minus 9x. And because the W is by itself, there's nothing I can simplify. This would be my final answer. So look at the next example. Solve for P. So again, P on the left and P on the right. Now the one on the right is trapped. So the left-hand side, I can just leave it as 6P plus 7 equals, if I distribute, I get RP minus R. Alright, so let me identify where the P's are. Again, I have two of them, and we know from previous problems that we want them on the same side. So I'm going to subtract. But now we have a problem. These are not like terms, and the reason they're not like terms is this one has a P and this one has an R and a P. They don't have the same variables. So I can't do the same thing I've done in previous problems. Since they're not like terms, I'm going to have to do the same thing I've done in every other problem where I don't have like terms, and just write them next to each other. And this equals a negative R. Alright, so let's... Since the P's are on the same side, that's good, but this one doesn't have any P's in it, so I'm going to at least move this over to the other side. So I'm going to subtract 7. I have 6P minus RP equals, these are not like terms, so I'm just going to rewrite them, keeping their sign values, as negative 7 minus negative R minus 7. So now here. So how could I possibly go down to 1P when I have two that are not like terms? Well, let's go back up to the original problem. Let's look at what we did here. Here I had a single R times the quantity P minus 1. After I distributed, I got down to this. I got down to two terms, each had an R, and they're not like terms. So when I distributed, I went from having one R to having two R's. And here I have two P's, and I'd like to move back to having one P. So what I'm going to do, since the P is common to both terms, I'm going to factor that out, which is called GCF factoring, or greatest common factor, or common factor. Okay, it doesn't always have to be the greatest one. We're used to GCF factoring. But because the P is common, what I want to do is pull that out, and that's going to leave me with 6 minus R. To show you that's the same as if I started with this and distributed it, I'd get 6P minus RP. Okay? And I didn't do anything on the right-hand side. So now I've gone from having two P's all the way down to having one P. So this is P times the quantity 6 minus R. So to get rid of that, I'm going to use the opposite operation, which is to divide by 6 minus R. So I have P equals negative R minus 7 divided by 6 minus R. Don't make the mistake of trying to simplify these negative R's. You can't, because the 6 minus R are combined into two separate terms. So just be careful. We are completely done, and we'll leave our answer like that. Alright, so each of you, I don't know if you noticed, each of these problems are getting a little bit more difficult. I'm adding an extra step each time. Here we're solving for K. So let's think about what we have to do in this problem. On the left-hand side, it's trapped inside, so I'm going to distribute. Now you could write y3, but we typically put the number in front of the variable. So I'm going to write 3y plus yk. With variables, it doesn't matter the order. Some people like to put them in alphabetical order. It doesn't matter. It's whatever you prefer. Minus 4k. Then let me think about where the k's are. And I like using this kind of box technique so it focuses my attention on what I want to do. These need to be on the same side. So what I'm going to do is subtract 4k from both sides. So this leaves me with 3y. Again, these are not like terms. I have yk and just a k. So I'm going to write plus yk minus 4k. And this should just equal 9y. So now both of the k's are on the same side, but I have a term with no k's. So it does me no good to keep it on the same side, so I'm going to subtract it to the other side. This leaves me with yk minus 4k. These are like terms, because there's just a single y. 9 minus 3 is 6y. Alright, so now I have the same issue that I had in the last problem. I have two k's, they're not like terms, so what do? Anytime you get to this step, you should factor out what is common. Or in this case, the k is what we care about. We're left with y minus 4. Always double check to make sure that you did your algebra correctly with factoring. Distribute and see if you get back to the previous step. Y times k minus 4 times k. So we're good. Trying to get k by itself. So I think, okay, k times the quantity y minus 4. So I want to divide by the quantity y minus 4. And I get a final answer of k equals 6y over y minus 4. Again, I cannot simplify these y's or take out a 2 from the 6 and 4 because these are not being multiplied together, being subtracted. So that would be my final answer. Let's go on to the next example. Alright, this kind of looks like the second one we had where we had fractions, but I have m's on both sides, but it's part of a fraction, so just like we did before, I'm going to cross multiply. So I'm going to do 7 times m plus 1 equals. Now this is why I like to write it out, because if you don't write it out correctly, you're going to get this wrong. I'm taking this quantity, which is a x minus 2, and I'm taking this whole thing and multiplying it by this quantity, m plus 5. If you don't use parentheses, you're going to make the mistake of only distributing the negative 2, or unless you wrote this one first, only distributing the positive 5. So let's think about where these m's are. Here's an m, here's an m. So we know we need to distribute. 7m plus 7 equals. We're going to distribute here. I know a lot of teachers use the word FOIL. Not always the biggest fan of the word FOIL because it only works when you have a binomial. 2 terms times a binomial, 2 terms. But what we're really doing is just distributing. We're taking the x times the m, then the x times the 5. Once we're done with that term, we go on to the next one. Negative 2 times the m, negative 2 times the 5. Now I'm going to reevaluate. I have an m here, I have an m here, and I have another m. Now I went from having 2, and now doing all the algebra that I have to do, I've now made the problem worse by now having 3. No matter what, I know they all need to be on the same side. But if you notice, I have a 7m and a 2m. So it might be easiest to move this m over first, because these are like terms. So I get 9m plus 7 equals xm plus 5x minus 10. So now I can reevaluate. I have an m here and an m here. Again, I want to get those on the same side, so I'm going to subtract xm from both sides. These are not like terms, so I'm going to have to write them out separately. Okay, plus 7 equals 5x minus 10. So let's look. M, but that 7 doesn't have an m, so it's not needed on this side, so I'm going to subtract 7 from both sides. I'm going to place it under the negative 10 because those are like terms. So I'm left with 9m minus xm equals 5x minus 17. Again, I'm just going to reevaluate where the m's are. I notice I have 2 m's on the left-hand side. I went from 2 to 3. Combine my terms, now I'm back down to 2. And I'm going to use my technique of factoring out an m, which leaves me with 9 minus x equal to 5x minus 17. Okay. And then I notice I have 1m, so I can go right to my final answer and go to 5x minus 17 all over quantity 9 minus x. Now, a lot of students like to go from this step all the way to this step, and they don't always do it correctly. I really, really, really need to see the step where you factor out this m. This is the whole key for these harder problems, and if you don't get in the habit of showing it, if I tweak the problem a tiny bit, you're going to have a really hard time getting to this final answer. Alright, let's look at this one. This one looks a lot simpler, but what I'm looking for is b. There's only one, and it's in the denominator, but this isn't set up like a fraction equal to fraction. There is no cross multiplying allowed right now. So what I'm going to have to do is think, how can I get this b alone? Well, it's trapped with the a, so the first thing I want to do is at least move the 5 over, because that doesn't have anything to do with the b's. So I have a over b equal to c plus 8. Now what happens a lot of times here is people are like, oh, okay, well I need to get the b by itself. So all I do is need to move the a. Since a is on the top, I'm just going to divide by a, and then b will be alone. Well, true, b will be alone, but it'll be in the denominator. And it doesn't say to have 1 over b be by itself or 1 over b, it says solve for b. So the best thing, and maybe the easiest thing I see most students prefer to do here, is I have a over b equal to c plus 8. Let's just make this a fraction. C plus 8 over 1. Now I can use the same technique of cross multiplication. 1 times a is a, and now here I have b times c plus 8. Now another reason why I like to always write out what I'm multiplying instead of just doing, oh, b times c plus 8 times b, is because writing out this way, the b is already by itself. If I distribute it, I have more work to do. So I know to get b by itself, all I need to do is divide by the quantity c plus 8, and now I have b is equal to a over c plus 8. And like I said earlier, it doesn't matter what side your variable's on the left or right, as long as you isolate it. And now we have b equals a over c plus 8. So hopefully you feel a little